All right, welcome to the Explainer. We're always told to work smarter, not harder. But what if I told you that for some of the toughest challenges out there, the smartest path is actually to use more brain power, not less? Yeah, today we're going to look at a cognitive model that just flips the whole idea of efficiency on its head. I know, it sounds completely backward, right? We're all taught that efficiency means doing more with less. But what if, just what if, for some of the most mentally demanding tasks, the complete opposite is true? So, to really wrap our heads around this, we first have to understand the kind of mind we're even talking about. You see, the source material here describes a cognitive architecture that doesn't try to simplify the world. No, it's built from the ground up to embrace complexity. At the very core of this whole model is a strategy called lookup table learning. Now, forget about creating broad general rules. This kind of mind builds a massive internal library. It basically memorizes the direct link between a specific situation and the perfect response. It's all about having an answer for everything, not just a formula to figure it out. And this sets up such a fascinating contrast. On one side, you've got the memorize everything strategy, which uses a ton of parameters to build this exhaustive library. And on the other, you have the approach we usually praise in AI, right? Being parameter efficient, using as little data as possible to make general rules. We're talking about two totally different philosophies for how to think. So this just begs the question, why would any system choose this brute force approach? I mean, why build such a gigantic internal library when you could just generalize? Well, the answer isn't really in the mind itself, but in the kind of world it has to deal with. The source material gives us this absolutely brilliant metaphor from a strategy game. Okay, so picture this. You're the black player, your opponent has just dropped 4 pieces right smack in the center of the board. The situation is incredibly complex, it's unpredictable, and it forces you to constantly think moves ahead. This is the kind of cognitive arena this mind is built for. When the world is just constantly throwing unpredictable curveballs at you, simple rules, they just break down. The only way to stay agile, the only way to compete, is to anticipate every possibility you can. And that is what forces the mind to build that huge library of responses. It's a direct result of the high-stakes game it's constantly playing. And listen, this isn't just about board games. Think about a hospital receptionist. They get these little partial cues, a name, maybe a symptom, a doctor's department, and they have to instantly fill in the blanks with perfect speed and accuracy. That kind of lightning-fast recall absolutely relies on a huge internal database of learned scenarios. All right, so what we've got is a mind that is intentionally complex, absolutely jam-packed with information. It sounds incredibly powerful, for sure, but it also sounds, well, exhausting. And that brings us right to the heart of the puzzle. How in the world can this possibly be efficient? Because here's the fundamental rule. In computational science, and this goes for everything from AI systems to biological brains, maybe even highly specialized biological units like our T cells, efficiency is defined by low effort. The goal is always to minimize how much energy you use to do the most with the least. And boom, there's our paradox. How can a system that is literally built on more parameters, more memory, more complexity, how can that possibly be considered efficient? It feels like a high-effort system in a universe where low effort is always the name of the game. Well, the solution to this paradox is actually incredibly elegant. This system doesn't break the low-effort rule at all. It finds a really clever way to cheat. It has a secret weapon for managing all of its own complexity. And that secret weapon is perfectly captured by this wonderful Dutch term, ezelsbruggetjes. It translates to little donkey bridges. And that's exactly what they are, mnemonic devices, little mental shortcuts that are consciously used to manage and optimize that massive computational load. They're the bridges that make this whole complex system actually work. And this right here is the key. These aren't just clever little memory tricks. This is a super powerful strategy called cognitive offloading. The mind is literally moving the hard work, the computational burden, away from active, real-time thinking and onto this pre-built, structured system of shortcuts. It's kind of like creating your own mental cheat sheet. But wait, there's more. These shortcuts also do something else that's vital. They act as a decompression strategy. You see, a mind that oversimplifies can get stuck in tunnel vision. But by using these mental tools to unpack ideas and expand its context, this system stays flexible. It's like a built-in defense against thinking too narrowly. So when we start to put all these pieces together, what we get is a completely new formula for efficiency. And it's not about one single trick. No, it's about three core pillars all working together in this really powerful system. So efficiency here really rests on three interconnected pillars. First, you've got the high parameters. That's the grand library of knowledge. Second, mnemonic offloading. Those are the strategic shortcuts you use to navigate the library. And third, you need a supportive ecosystem. Remember that high-stakes game? Well, this system works best when the rules of the game are clear, giving it the structure and the cues it needs for those shortcuts to be really effective. And that brings us to the most important takeaway of all. For these highly complex, super specialized systems, efficiency isn't about minimalism. It's not about having fewer parts. Efficiency is achieved by strategically optimizing the use of a vast and complex internal world. It's all about smart management. And that leaves us with a pretty provocative final thought. In this race to build smarter and smarter AI, we're all obsessed with efficiency, making them do more with less. But what if we've been looking at it all wrong? What if the true path to real artificial intelligence isn't about minimizing complexity, but about mastering it?